Dear students, in this lecture we are going to discuss about the sandwich theorem statement and the problems which are related to sandwich theorem and the problems of exercise 8a which are related to the concept of a limit. Now see the sandwich theorem. So the sandwich theorem which refers to a function f whose values are sandwiched between these two functions g and h. So that have the same limit, means the f that has a same limit at a particular point a. So let us see the statement of this theorem. So just you need to learn the statement of the sandwich theorem. Suppose that so the three functions f, g, h, here f is sandwiched between the functions g and h like this. G of x is less than or equals to f of x is less than or equals to h of x. So for all x is in some open interval that containing a particular point, so let it be that is a, except possibly at the particular point x is a, except possibly at x equals to a itself. And so one more thing, the limit of g and h are exist at the same point x equal to a and both are equal, means limit extends to a, g of x is exist, and limit extends to a, h of x. Both are exist and they are equal to a limit L. Then the limit of f of x at the same point x equal to a is L. Limit extends to a, f of x is also L. So whenever these three functions satisfies, so g of x less than or equal to f of x is less than or equal to h of x, then so the limit at x equals to a for all the functions is same. See geometrically, so we can observe the graph of these three functions. So let us consider the function c, let it be, so this is our h function, and so this is g, so like this, g is less than or equals to f of x is less than or equal to h of x, so h of x is always high, and so in between these two functions, so there is a other function that is our f. So let it be the function, so like this. So here so this is our f function. Now so here at x equals to a, see in the statement it states that so in an open interval that containing a except possibly at x equals to a. So if the function value at x equal to a is not defined, also no problem. So let it be this is our whole. So at x equal to a, at x equals to a, this is that indicates L, function value L. This is the statement of a sandwich theorem. So now you need to remember the statement for sandwich theorem. So here so we can apply this theorem for solving some problems, so which are difficult to find the limit of f of x. So by using this concept, so we can evaluate the limit of f of x by finding the limits of g and h. So we can estimate the value of f of x at x equals to a, the limit of f of x at x tends to a. So for example, so the given inequality 1 minus x square by 4 less than or equals to f of x is less than or equals to 1 plus x square by 2 and x is non-zero. Then find the limit of f of x at 0. See here, so you can observe from this inequality, so we don't know what is the function for f of x, but the function, whichever the function is exist here, that will be in between 1 minus x square by 4 and 1 plus x square by 2 only. Now see here, so you can apply the inequality is in the form of g of x less than or equal to f of x is less than or equal to h of x. So here g of x is given that g of x value is 1 minus x square by 4 and h of x is 1 plus x square by 2. Now, so you can apply the limit for these two functions, since x square 1 minus x square by 4 and 1 plus x square by 2 are polynomials. So apply the limit for both the functions. Limit x tends to 0. Now 1 minus x square by 4 is exist, that is 1 minus 0 by 4, which is 1. And similarly limit x tends to 0. Now so 1 plus x square by 2, 1 plus x square by 2. Now so this is 1 plus 0 square means 0 by 2, so this is also 1. So here we can observe that limit x tends to 0, g of x is exist, and limit x tends to 0, x tends to 0, h of x is also exist, and both are equal to 1. Now here so we can observe one point from the sandwich theorem. So it is g of x is less than or equal to f of x is less than or equal to h of x, and the limit of both the functions g and h are exist at x equal to 0 and are equal. So therefore by sandwich theorem, here we can conclude that so this implies that the limit x tends to 0, the function f of x is also 1 from sandwich theorem. So limit x tends to 0, f of x is equals to 1. So the next problem, here find limit x tends to 0, x square into cos of 2 by x. Here so you know how to find the limit of this function. Here what is f of x? F of x is x square into cos of 2 by x. So directly you can apply the limit also, no problem. So it is x square into cos of 2 by x. 2 by x is here 2 by x, 2 by 0, that is infinity. So it is a cos of infinity, means as x is goes to 0, then so this will be oscillating between minus 1 and plus 1. So we don't know the exact value of cos of that infinity, minus 1 and plus 1. It will be oscillates between minus 1 and plus 1. But 0 into that is, so obviously it is 0. So the limit x tends 0, x square into some finite value is always 0. So that is one thing. And so here we can find the value of this function x square into cos of 2 by x by using sandwich theorem. See here from the trigonometry we know the range of cos x, right? So the cos of x is anything, but the output values are from minus 1 to plus 1 only. So here we know that the cos x is from minus 1 to plus 1 only. Minus 1 is less than or equals to cos x is less than or equals to 1. Or so cos x is anything, it will be minus 1 to plus 1 only. So here I am writing this minus 1 is less than or equals to cos of 2 by x. This is also no problem. Here x is anything. So the range of cos x is always from minus 1 to plus 1 only. Now, so here so we need to get this is x square into cos of 2 by x. So that so you can multiply on both sides or the entire inequality with x square. Then there is no issue. So x is anything, any value, but x square is a positive quantity. So there is no change in the inequality. So that it is minus x square is less than or equals to x square into cos of 2 by x which is less than or equal to x square. Right now, so here, so this is in the form of g, f and h. So g of x is less than or equal to f of x is less than or equal to h of x. Now you can evaluate the values. The limit at x tends to 0 for the left and right function of f. So limit x tends to 0, here minus x square find it in. Minus x square, that is minus 0 square, means it is 0. And other function h, that is limit x tends to 0, this is x square. X square is 0 square, so therefore the limit is 0. Therefore by sandwich theorem, so sandwich theorem prakaram emutundi, the limit of f of x, so the limit of g and limit of h are exist and they are equal. Therefore by sandwich theorem the limit of f of x is also same at the given point. Therefore by sandwich theorem, limit x tends to 0. Now f of x is x square into cos of 2 by x is 0. So therefore the limit of this function at x equals to 0 is this one. So students, now we will solve some problems from exercise 80. So I will solve some problems and you need to solve the leftover problems, so which are similar to what I am going to explain now. So first, so we will see from the first Roman, so fifth one I am taking, since 1, 2, 3, 4, so you can do. So this is limit x tends to 1, so 2x plus 1 divided by, so this is 3x square minus 4x plus 5. So this is in the form of f by g model. So whenever the function is a rational function or f by g model, so you need to check the denominator at the given limit. So here the limit is x tends to 1, right? So if we substitute instead of x is 1, that is 3 minus 4 plus 5. So 3 plus 5, 8, 8 minus 4, that is 4 only. So there is no issue with x equal to 1, since it is valid, so that we can divide this numerator with that 4. So simply you can find the limit for this solution, that is limit x tends to 1, 2x plus 1 divided by 3x square minus 4x plus 5. So which is, so 2 into 1 plus 1 divided by 3 into 1 square minus 4 into 1 plus 5. Then so this is 2 plus 1 divided by 3 minus 4 plus 5. So this is 3 divided by 4. So therefore the limit of 2x plus 1 divided by 3x square minus 4x plus 5 as x goes to 1 is 3 by 4. So let us take another problem, that is sixth problem from your exercise 8a. That is limit x tends to 1, x square plus 2 divided by x square minus 2. Now, so is there any problem at x equals to 1 for the denominator? So it is 1 square is 1, 1 minus 2, so there is no issue. So directly you can apply the limit. So this is 1 square plus 2 divided by 1 square minus 2, that is 1 plus 2 by 1 minus 2. So this is 3 divided by minus 1. 3 by minus 1 is, so minus 3. So the limit of this is minus 3 at x tends to 1. Okay, now 7th and 8th, so you can solve 7th and 8th. So let it now 9th one. This is limit x tends to 0, x to the power of 3 by 2, x to the power of 3 by 2. So here it is mentioned x is greater than 0. So why he is mentioned x greater than 0? So if x is any real number, so there is an issue with left hand side of 0. Left hand side of 0 means negative values. So here x to the power of 3 by 2 is there. x to the power of 3 by 2 means, so this is a x cube whole to the power of 3 by 1 by 2. 1 by 2 means it is a square root. So root of negative quantity is never defined. So it is x is greater than 0. So that so here the value of x is more than 0. So that directly you can apply the limit for this. So that is 0 power 3 by 2. 0 power 3 by 2 means 0 only. Okay, if x is any real number, then the problem is does not the limit of limit at x tends to 0 is not exist. So compulsory you need to mention x is greater than 0. If simply limit x tends to 0, x power 3 by 2 is not exist, just you need to mention the limit for this function at x tends to x equal to 0 is not exist. Then so similar one, that is 10th. So limit x tends to 0, so it is root x plus x to the power of 5 by 2. Here also x is greater than 0. X is greater than 0. Then same. So root of 0. Then this is root 0 plus 0 power 5 by 2. Then this is 0 and so this is also 0. So finally it is 0. The limit for this 10th problem is also 0. Next, 11th and 12th. So solve 11th problem and 12th problem by your own. Next, 13th. Limit x tends to 1. This is x minus 1 divided by x square minus x minus 1 divided by, here this is x cube minus 3x square plus x. So this is limit x tends to a f of x minus g of x form. So that we need to apply the limit for both the functions. So like, then so we can write this as a limit x tends to 1 f of x, that is x minus 1 divided by x square minus x, minus limit x tends to 1 by x cube minus 3x square plus x. Right now, so here for each and f function f and g, the denominator is exist. So the denominator is not exist at x equals to 1 for the first function. If we put x equals to 1, then it is 1 minus 1, so 0. So we cannot divide the numerator with 0. So that so we need to create a common factor for both numerator and denominator and cancel the common factor. That is limit x tends to 1. So this is x minus 1 divided by, here we can express it as x into x minus 1, right, minus limit x tends to 1. So here it is no problem with this. So directly you can apply the limit. Then this is 1 cube minus 3 into 1 square plus 1. Now, so here common factor is x minus 1. So x minus 1 gets cancelled. Then so this is 1 minus, so this is 1 cube is 1 minus 3 plus 1. Then this is 1 minus 1 by 2 minus 3. That is 1 plus 1, which is 2. So the limit of this function is 2. So it is 1 by 2 minus 3, minus 1, minus 1, minus 1. So it should be a plus 1. So 1 plus 1 is 2. Next, the 14th one, that is limit x tends to 3. Now it is x to the power of 4 minus 81 divided by 2x square minus 5x minus 3. Now, so again it is in the form of f by g. Now so you need to check the denominator at x equal to 3 first. So this is 2 into 3. So it is 2 into 9 minus 5 into 3. So it is 15 minus 3. So 18 minus 18. So this is 0. So that so we need to create a common factor from numerator and denominator, and so cancel out. So cancel the common factor. So that we can express it as a limit x tends to 3. Now, so in this case the common factor is compulsory x minus 3 only. So here x power 4 minus 81 is there. Now we can write this as x square whole square minus 81 as 9 square divided by, now so here it is a quadratic expression. So you can factorize like 2 3's, 2 into minus 3, so minus 6, and minus 5 can be written as minus 6 plus 1. Then it is 2x square minus 6x plus x, sorry, it is minus 3. Now, so the numerator is a square minus b square form. Here a is x square and b is 9. So we can express it as x square minus 9 into x square plus 9. Then, so this is 2x. So from these two terms 2x is common. 2x times of x minus 3, and here it is plus 1 times of x minus 3. Now, so in the numerator the common factor x minus 3. See here x square minus 9 is there. X square minus 9 means x minus 3, or it is x square minus 3 square form, right? So we can express this as x minus 3 into x plus 3. So this is x minus 3 into x plus 3 into this is x square plus 9 divided by, here in this x minus 3 is common, this times of, so the remaining part is 2x plus 1. Now, so we got the common factor x minus 3, then it will be gets cancelled. Now, so apply the limit. So as x is goes to 3, then x plus 3, that is 9 into x square means 9 plus 9 by, so 2 into 3, so it is 6 plus 1. Now, so this is 9 into, sorry, so this is 6, right? Limit x tends to 3, x plus 3 is 6. So 6 into this. So this can be written as 6 into 18. 6 into 18 by 7. So 6 18s are 108 by 7. So the limit for this function at x tends to 3, at x equal to 3 is this one, 108 by 7. So similarly 15th problem, so you can do. So it is also in the form of f by g. You may get the common factor x minus 3, right? The next 16th one, if f of x is minus square root of 25 minus x square, then find limit x tends to 1, here f of x minus f of 1 by x minus 1. Now, so here f of x is given that f of x, what is our f of x? F of x is minus square root of 25 minus x square, and so by using this so you can find the function value at 1, that is f of 1 is what, minus root of 25 minus 1 square, that is 1. So this is minus root of 24. So f of 1 value is minus root 24. Now here what we have to find? So we need to find the limit x tends to 1, f of x minus f of 1 divided by x minus 1. Now, so replace all the values here. So limit x tends to 1, f of x means it is a minus root of 25 minus x square, and So f of 1 is minus root 24. So already minus is there. So we can write it as a plus root 24 divided by x minus 1. Now, yeah, we have a limit extends to a f of x by g of x form now. So here, so you need to check the denominator first. X minus 1 and x is goes to 1. So then obviously it is 0. So something by 0, then it is, or it is, we cannot divide this something with 0. So that we need to create a common factor by using the rationalization for the numerator. As we seen in the previous lecture, one problem, right? So this is related to the same problem. Now here first you need to write, so this as minus is there. So let us take a minus is common. Minus is common, therefore it is limit extends to 1. So ఇక్కడ minus common this అవుతుంది root of 25 minus x square and this is minus root 24 అవుతుంది. Minus common this is divided by x minus 1. Now so you can rationalize this numerator with root of 25 minus x square plus root 24 divided by root of 25 minus x square plus root 24. Right? Now, so here you can observe, so this is like a minus b form. Let it be this a and b, then it is also ab. So a minus b into a plus b form. Minus, this is limit extends to 1. So a minus b into a plus b is, so this is a square minus b square, right? Root of 25 minus x square whole square minus root 24 whole square divided by, this is as it is, so it is x minus 1 into root of 25 minus x square plus root 24. Now here square root and square root gets cancelled. Then so this is minus limit extends to 1. Then this is 25 minus x square minus 24 divided by x minus 1 into, then so this is a root of 25 minus x square plus root 24. Then so this is 25 minus 24, that is 1. So we can express it as a minus limit extends to 1. Now it is 1 minus x square divided by x minus 1 into root of 25 minus x square plus root 24. Right? Now, so you can simplify here. Now, so again it is a 1 minus x square is there. 1 minus x square, which can be expressed as a 1 square minus x square. 1 square minus x square, that is minus limit extends to 1. 1 minus x square as 1 square minus x square, that is 1 minus x into 1 plus x. Now so divided by this is x minus 1 into root of 25 minus x square plus root 24. Then so this is, so you can multiply with the negative sign, therefore 1 minus x, that becomes x minus 1. Then it is limit extends to 1. Then this is our x minus 1 into x plus 1 divided by x minus 1 into root of 25 minus x square plus root 24. Now here x minus 1 and x minus 1 gets cancelled. So common factor into cancel అయిపోయింది. Now so you can apply the limit directly. So that it is x tends to 1, x plus 1 is 2 divided by, so this is root of 25 minus 1 square, that is root 24 plus root 24. So root 24 and so this root 24, that is 2 by 2 into root 24. So 2 and 2 gets cancelled, therefore it is 1 by square root of 24. So therefore the limit of this function is 1 by root 24 at x equals to 1. This is root of 24. So students, so go through all these problems which I am explained in this lecture once again, and solve the leftover problems of your exercise 80. So most of the problems are related to, so these concepts only, are they are very easy, so you can evaluate, as well as solve the problems which are given in the problem set, like solved problems. So do solve all the problems which are given there in the textbook. Thank you.